The first thing we're going to talk about is planning the job. You'll remember that the 4 basic steps in planning any rigging job are finding the weight, checking the balance of the load, making sure you've got room to move the load, and selecting the equipment. Let's go through these steps one at a time. Norris is responsible for getting this unit moved to the floor below for installation. The first thing he's going to do is size up the job by finding the weight of the load. One place to find the weight is on an equipment nameplate. But unfortunately, this pump and motor assembly doesn't have a nameplate that lists the total weight. Since he can't find the weight listed right on the load, he turns to another source of information, the equipment manual. It lists the weight of the unit as 650 pounds. If he didn't have this listing, he could look at the shipping papers or estimate the weight of the load by comparing its size to that of a similar piece of equipment whose weight is known. After finding the weight, Norris estimates the balance of the load. Experience has shown that the pump will be the heaviest part of the load. As he eyeballs his sling lengths, he figures that the balance point will be off-center, closer to the pump. If the load is picked up from the center, it'll tilt. To level the load, the main load hook has to be directly over the center of gravity. For this load, it's convenient to use 3 slings, but 2 of the legs must be shortened to adjust the balance of the load. Norris decides to use turnbuckles to adjust the lengths of the slings. It's not so great an adjustment that he'll have to use a load leveler. Since the pump is the heavy end, the hook will have to be closer to that side of the load. The 2 slings on the pump end will have to be shorter than the single sling attached to the motor. Now that Norris has found the weight of the load and estimated its balance, he's ready for the next step. Where's the load going? First, the pump and motor unit will be picked up from its present position. Attached to an overhead crane, it will travel down a narrow corridor. Once out on the floor, it will have to turn several corners to avoid obstacles. Once the load is in the right position, it'll be lowered down a shaft to the floor below. A hoist is attached to the overhead crane so the load can be lowered slowly and precisely through the shaft. What Norris has to check now are clearances. To see if the load will fit through the route he's planned, he measures the load carefully. First, he measures the width. That will tell him the size of the smallest corridor the load will fit through. Next, to make sure the load is short enough to fit through the shaft, he measures the unit's length. When he has all the dimensions of the load, he's ready for the next step, checking clearances along the way. Norris plans to take the load through this narrow space to avoid having to lift the load over the top of anything. He measures the width of the corridor at its smallest point. It's just barely wide enough, so he'll be able to maneuver the load while it's close to the floor, even if it is tight. The last thing he has to measure is the shaft clearance. The load will have to fit through the shaftway without banging against any of the sides. First, he measures the length of the shaft. It's more than long enough for the load. There'll be about 1 foot on either side. Next, he measures the width of the shaft. Although the shaft won't be especially tight, it's close enough that extra care will have to be taken when the load is being lowered to the floor below. There's one more thing Norris has to do before he can begin selecting his equipment. Since an open shaft will be a hazard to other workers on the floor, it has to be surrounded with safety cones or barriers before the grating is removed. Before he can start the job, he has to figure the correct number of cones and place them around the opening, allowing plenty of room for him and his crew to work. Now, he has all the information he needs to plan the job. He knows the weight and balance of the load, and he's checked his clearances, so he's ready to decide just what equipment he's going to need. Let's start from the bottom up. The load will be picked up from these 3 eyes. Each eye will need a shackle, so we can attach the next piece of equipment. Norris has already decided to use a 3-legged sling with 2 turnbuckles to balance the load. Its 3 legs attached to the shackles on the eyes. Next comes a hoist. so the load can be lowered slowly through the shaft opening, where clearances are fairly tight. The whole assembly attaches to the load hook of the overhead crane with a wire rope sling and a shackle. The overhead crane provides the travel to take the load where it has to go. The rigging will have to support 650 pounds. To be on the safe side, Norris figures in an extra safety margin even though the rated capacity of each piece includes a safety factor already. Once he's completed his list of materials, Norris goes to the tool room and draws the equipment. Each piece has been carefully checked by the tool room man, but that doesn't mean he won't check it again. He'll double check everything before he mounts a single piece. In a few minutes, we'll be back to watch the inspection. But first, let's review what we know about planning a rigging job. First, find the weight of the load. Every piece of equipment has to be rated at least that high. Second, estimate the balance of the load. If the load must be leveled, you'll need an adjuster of some kind. Third, check clearances. It's awfully embarrassing to get stuck because you didn't measure the tight places along the way. The fourth and last step in planning any rigging job is selection of the equipment. Once you know the weight of the load, its balance, and the clearances you have to work with, you know what your equipment has to be able to do. But it never hurts to add that extra margin of safety. While Norris has the rigging equipment taken to the job site, we're going to pause briefly so you can read section 1 of your text and work the exercises. When we return, we'll be taking a detailed look at the inspection procedure, and we'll watch Norris go to work preparing for the job. Preparing for the job is the next step in our rigging demonstration. So far, we've watched as Norris planned the job. He found the weight of the load, estimated its balance, made sure he had room to move the load, and selected the necessary equipment. So there are really only 2 more things he has to do before he can mount the rigging on the load. He has to inspect the equipment and organize his crew. We're going to start with the inspection process. Now you'll notice that Norris uses a checklist. That way he keeps an accurate record of the condition of each piece of rigging. And he can be sure he hasn't missed anything before he actually rigs the job. The first thing he has to check is the condition of the eye bolts. These are shoulder-type eye bolts. He checks the pins for straightness, inspects the threads, and makes sure the eyes haven't been stretched or cracked by overloading. After inspecting both eye bolts, he marks them off as okay on his checklist. The next item is shackles. He'll need 7 of them. As he inspects each shackle, he checks the shape of the shackle body. Overloaded shackles may look stretched and pinched together. Next, he unscrews the pin. It moves freely, without binding. If it was binding, Norris would suspect that either the pin was bent or its threads had been damaged. A close inspection of the threads shows them to be in good shape. No damage. Both eyes are round, and no cracks are visible. After inspecting each shackle, he moves on to the next item on his list, turnbuckles. Norris checks each turnbuckle's body for cracks or bending that might mean that the piece had been overstressed on some earlier job. Then he checks the action of the screws, looking at the threads to see if they're stretched or stripped. Finally, he inspects the eyes on the screws. They appear to be undamaged, no cracks or wear, and they haven't been bent, so one more item can be marked off on the checklist. The next part of the inspection is inspecting the slings. Wire rope slings have to be checked for several kinds of damage, kinks, unraveling, and broken wires. Shiny flat spots on the rope would indicate places where it's been crushed or badly worn. Both eyes should be checked to assure they haven't been kinked when too heavy a load was put on the sling. Measuring the diameter of the rope is a good way to see if the sling's been overstressed. Measurements should be taken at several points along the length of the rope. If the diameter is less than 90% of that of a new rope, don't use the sling. It's been stretched by overloading and is no longer safe. These slings measure the same as a new rope. They've never been misused. After checking all 4 slings, Morris is almost at the end of his checklist. Only one more item remains: the hoist. On any chain hoist, there are 4 things that have to be checked before every use: the top hook, the load hook, the chain, and the mechanism itself. Both hooks are inspected for the same kinds of possible damage: cracking and spreading. Norris has a gauge for this hoist that makes his job easier. His shop has made one for each kind of hoist they use, and each one is marked to identify the make of the hoist and its capacity. He uses the large end of the gauge to check the hook for spreading. It tells him that the hook is all right. It barely drags on either side of the throat as it's inserted. A gap of 1/8 of an inch or more would be a sign of overloading. The small end of the gauge is used to check the load chain for stretch. When it's inserted between links, only the smallest part of the gauge should be able to enter. If the gauge enters farther than that, the hoist needs repairs. It should be reported to a supervisor. Norris completes the chain inspection by examining the links for cracks, wear, broken welds, and finally, the anchor bolt. Once he's convinced that the chain is in good shape, he can turn his attention to the other working parts of the hoist. The hand chain moves smoothly and easily. If it didn't, it would be a sign of damaged internal parts or not enough lubrication. Either problem would be enough to warrant removing the hoist from service. Now Norris has inspected all the equipment he needs for his part of the job. He checked the eye bolts, the shackles, the turnbuckles, the slings, and the hoist. The overhead crane will be carefully inspected by its operator. On some of your rigging jobs, though, you're likely to need equipment that Norris didn't have to bother with. For example, you might be using nylon slings or a load leveler. If you're using nylon slings, inspect them along their length for cuts or excessive wear. On this kind of sling, nylon fibers of a darker color are embedded in the material to indicate worn places on the sling. Where the material is worn especially thin, the darker colored fibers will show up on the surface. There are 4 things to check on a load leveler: the hooks, the chain, the mechanism inside, and the eye on the top of the casing. These are the same things you check on a hoist or a come-along. First, inspect the hooks for cracks. They are likely to occur along the inner surface of the shank. Next, check the hook for spreading. If you don't have a gauge, measure the opening with a rule. Find the size of the new hook by looking in a rigging handbook. Then compare your measurement to that figure. If your hook is spread more than 15%, it's not safe to use. Next, inspect the chain. Check the links for cracks, broken welds, and worn spots. If any one link is damaged, the whole chain's no good. Overloading will damage every link, but you can't always see the result. Finally, check the chain for stretch. One way is to use a gauge, as we saw before. Now, if you don't have a gauge, measure the length of a 5-link section. Compare this measurement to the nominal figure given in a rigging handbook. If it's within 10%, the chain is okay to use. The next part of the inspection is to check the action of the internal parts. The hex adjuster should rotate the sheaves smoothly in either direction. If it's hard to move, it's time to take the load leveler in for repairs or lubrication. Now here's the last thing to check: the eye on the top of the casing, here. The telltale signs of overloading would be cracks or stretching of the eye. If there's no damage, the load leveler is ready to use. Every piece of rigging equipment has to be thoroughly inspected before use. That's the first part of preparing for any rigging job.